Did you ever notice that your engine responds differently every day? There are days when it starts perfectly and accelerates immediately. Other days it takes time to start and the response to the pedal is slow. It is not your madness, the engine changes its behavior daily due to multiple factors. Today we are going to identify the 14 causes why your engine does not respond consistently. From mechanical problems to defective sensors and contaminated fuel. The reason number 1 is shocking and most ignore it completely. This is valuable information to diagnose and resolve before a costly visit to the workshop. Let us go there. Reason 14. Worn accelerator pedal position AP sensor. The worn accelerator pedal position AP sensor generates an inconsistent signal. The electronic accelerator pedal has two sensors, AP1 and AP2, which send voltage signals to the ECU indicating the position of your foot. The resistive carbon tracks of the sensors wear out with use and time, creating an irregular contact. This wear generates erratic signals that the computer misinterprets regarding the pedal position. There are days when the sensor works correctly, and others when it sends a weak or intermittent signal. The classic symptom is an inconsistent throttle response. Some days the throttle is sensitive, others you need to press it to the floor to get a response. Verification is done with a voltmeter measuring the output signal from the sensors. It should increase linearly from 0.5 volts to 4.5 volts when pressing the pedal. If the signal jumps between values or there is intermittency, the sensor is defective. The power supply to the sensors is 5 volts and ground from the ECU. You must check the wiring and continuity. The repair is the replacement of the complete pedal at between 150 and 200 euros. Some vehicles allow calibration with an automotive scanner to restore the correct signal. Reason 13. Dirty or clogged air filter. The dirty or clogged air filter restricts the airflow to the engine. The internal combustion engine needs an exact mixture of air and fuel to function optimally. The air filter captures dust, particles and dirt to prevent them from entering the engine. A clogged filter restricts the amount of air that enters, reducing power and response. Partial clogging generates inconsistent behavior. On humid days, the filter absorbs moisture and the clogging is worse. On dry days, the filter allows more flow and the engine responds better. The symptom is that the engine responds differently depending on weather conditions, humidity and temperature. Verification is a visual inspection of the filter with a bright light through it. If the light does not pass through, replacement is necessary. The paper filter should be replaced every 15 or 20,000 kilometers depending on conditions. The washable high-flow filter can be cleaned every 30,000 kilometers. The replacement cost of the filter is economical, between 15 and 30 euros. Many owners ignore air filter maintenance, thinking it is a minor component. The reality is that a dirty filter significantly affects engine performance and fuel economy. Reason 12. Carbon accumulation on intake valves. Intake valves with carbon accumulation are a problem for GDI direct injection engines. In direct injection engines, fuel is injected directly into the cylinder, so it does not wash the intake valves. Oil vapors from the crankcase and EGR recirculation gases deposit on the valves, forming hard carbon. Carbon accumulation reduces the airflow area in the valves and affects the filling of the cylinders. On days when the engine is cold at startup, carbon accumulation restricts the flow more and the idle is irregular. With the engine hot, the thermal expansion of the carbon reduces the restriction and the engine responds better. The symptom is irregular idle on cold start, loss of power at low speeds, but when the engine warms up, it improves. Verification is an inspection with a bore scope, a camera in the combustion chamber to see the valves directly. Cleaning is the walnut blasting procedure where crushed walnut shells are fired at high pressure onto the valves to remove the carbon. The cost of cleaning is between 600 and 800 euros in a specialized service. Prevention includes cleaning additives in the fuel and quality oil that prevent accumulation. Sporadic driving at high revolutions helps burn off deposits. Some manufacturers add dual injection, port and direct, which solves the problem but adds cost and complexity. Reason 11. Contaminated mass airflow MAF sensor. The contaminated mass airflow MAF sensor gives an incorrect reading of the mixture. The MAF measures the exact amount of air entering the engine and sends the signal to the ECU to calculate how much fuel to inject. The sensor element, a hot wire or hot film, becomes contaminated with oil, dust and residues. Contamination generates erroneous readings and the ECU injects incorrect fuel, creating a lean or rich mixture. There are days when the sensor works acceptably and others when the readings are completely wrong. The symptom is that the engine starts with difficulty, unstable idle, poor acceleration, and fuel consumption increases. Verification is done with an automotive scanner to see the real-time values of the MAF. At idle, it should mark between 2 and 7 grams per second, depending on the engine. During acceleration, the values should increase proportionally. If they jump or are erratic, the sensor is defective. Cleaning is done with a specific MAF cleaner spray. Never use other chemicals that damage the sensor element. You apply the spray directly to the sensor element and let it dry completely before reinstalling. The cost of the MAF cleaner is €15. The replacement of the sensor costs between €150 and €300. Reason 10. Worn spark plugs with eroded electrode. Worn spark plugs with eroded electrode generate a weak and intermittent spark. Spark plugs ignite the mixture of air and fuel in the combustion chamber, where is normal with use. The central electrode of the spark plug erodes and the gap or opening increases, making the spark weaker. An excessive gap requires more voltage to generate the spark and the ignition coils work harder. On days of high humidity, electrical resistance increases and worn spark plugs fail to ignite consistently. On dry days with low humidity, the spark is stronger and the engine works better. The symptom is difficult starting on humid mornings, irregular idle, misfires during acceleration. The engine works better on dry days and high temperatures. Verification is the extraction of the spark plugs and visual inspection. You look for worn electrode, excessive gap, or cracked ceramic. The gap must be within the manufacturer's specification, typically between 0.8 and 1.1 millimeters, measured with a feeler gauge. Platinum or iridium spark plugs last 100,000 kilometers. Conventional ones last 30,000 kilometers. Reason 9. Weak battery with inconsistent voltage. A weak battery with inconsistent voltage affects the electronic systems of the engine. The battery provides the electric current for starting and powers the electrical systems when the engine is off. An aging battery has reduced capacity and the voltage drops with the demanded load. On cold days, the battery capacity is drastically reduced because the internal chemistry slows down. Low voltage affects the fuel pump, sensors, and control modules, generating inconsistent performance. On hot days, the battery works better with stable voltage, and the engine responds normally. The symptom is slow starting, the engine turns weakly, and the dashboard lights are dim during starting. The engine starts and works, but the throttle response is inconsistent because the electronic systems have insufficient voltage. Verification is done with a voltmeter measuring the battery voltage with the engine off. It should mark 12.6 volts with a full charge. With the engine on, it should mark between 13.8 and 14.4 volts with the alternator charging correctly. If the voltage drops below 12 volts under load, the battery is weak and needs replacement. Reason 8. Fuel contaminated with water and sediments. Fuel contaminated with water and sediments clogs the injectors. Fuel quality varies from gas station to gas station because storage tanks are contaminated. Water from condensation in the gas station fuel tanks and sediments and rust accumulate at the bottom. Contaminated fuel causes partial clogging of the injectors with an irregular spray pattern. There are days when the tank has clean fuel and the engine works perfectly. Days when the tank has contaminated fuel and the response is poor. Partially clogged injectors generate a lean mixture in the affected cylinders with loss of power. The symptom is irregular, idle, misfires, poor acceleration, and fuel consumption increases. The engine works erratically, especially after filling the tank at a dubious gas station. Verification is done with an automotive scanner looking for fault codes in specific cylinders. P0300 to P0308 for misfires. Visual inspection of the fuel in the tank looks for separated water at the bottom or sediments. Water in the fuel generates codes, P0087 for low fuel pressure. The solution is water drying additives in the fuel that absorb water in small amounts. Injector cleaning with cleaning chemicals or additives in the fuel for continuous use. The ultrasonic injector cleaning service in a specialized workshop costs between €200 and €400. In severe cases, full drainage of the fuel tank and cleaning of the tank is necessary. We have reached the middle of the list of the 14 reasons why the engine does not respond the same every day. The next 7 include critical problems that most ignore, complex diagnosis, and effective solutions. We are going to talk about crucial systems of temperature, pressure, and electronics. Reason number 1 is shocking, common, and devastating. We continue. Reason 7. Coolant temperature sensor ECT with incorrect reading. The coolant temperature sensor ECT with an incorrect reading generates an erroneous fuel strategy. The ECT measures the engine temperature and sends the signal to the ECU to adjust the fuel mixture and ignition timing. A cold engine needs a rich mixture and elevated idle. A hot engine needs a lean mixture and normal idle. A defective sensor sends an incorrect signal and the ECU thinks the engine is cold when it is hot or vice versa, making erroneous adjustments. There are days when the sensor reports low temperature and the ECU injects excessive fuel. The engine chokes with high idle. Days when the sensor reports high temperature and the ECU reduces fuel, creating a lean mixture with loss of power. The symptom is difficult starting, irregular idle, and erratic fuel consumption depending on the temperature. Verification is done with an automotive scanner comparing the ECT temperature with the real engine temperature using an infrared thermometer. The ECT should show ambient temperature with the engine cold and increase progressively while the engine warms up. A frozen reading or unreal temperature indicates a defective sensor. Reason 6. Fluctuating fuel pressure. Fluctuating fuel pressure due to a defective pump, regulator, or check valve affects performance. The fuel system must maintain a specific pressure for the injectors to spray correctly. The fuel pump pressurizes the system, the regulator keeps the pressure constant, and the check valve retains the pressure when the engine is off. A worn pump generates inconsistent pressure. Some days it works correctly, others the pressure is low. A defective pressure regulator allows the pressure to fluctuate, generating a rich, lean, or erratic mixture. A bad check valve allows the pressure to drop when the engine is off and the next start is difficult. The symptom is prolonged starting where the engine has to turn for several seconds before starting while the fuel pressure builds up. Irregular idle, poor acceleration, and loss of power, especially during heavy acceleration. Verification is done with a fuel pressure gauge connected to the injector rail to measure the pressure with the key in the on position and the engine off. The pressure must be within specification, typically between 3 and 4 bar for port gasoline engines or between 50 and 120 bar for GDI. If the pressure fluctuates erratically, the pump or regulator is defective. If the pressure drops rapidly with the key off, the check valve is bad. Listen to the fuel pump with the key in the on position. It should hum for 2 seconds to pressurize the system. If the pump is silent or does not work, check the fuse, relay, and power supply. Reason 5. Stuck engine thermostat. The stuck engine thermostat generates an incorrect operating temperature that affects performance. The thermostat regulates the flow of coolant to the engine to maintain the optimum operating temperature between 90 and 95 degrees Celsius. The thermostat stuck open means the engine never reaches the correct operating temperature. The cold engine needs a constant rich mixture with high fuel consumption and loss of efficiency. The thermostat stuck closed means the engine overheats with risk of serious damage. The operating temperature directly affects combustion efficiency, oil lubrication, and thermal expansions of the components. On days with low ambient temperature, the engine stays cold longer. With the thermostat open, it never warms up correctly. On hot days, the engine reaches temperature quickly and works better. The symptom is that the engine takes time to warm up. The temperature gauge never reaches the center and fuel consumption is high. The interior heating is weak because the engine is cold and insufficient. Overheating causes the temperature gauge to be in the red zone with steam coming from the hood. Verification is monitoring the temperature with a scanner. The engine should reach between 88 and 95 degrees Celsius in 5 to 10 minutes of normal driving. With the thermostat open, the temperature stabilizes between 70 and 80 degrees and never reaches the optimum. If the engine reaches temperature slowly, the thermostat is opening prematurely. The physical test of the thermostat is to extract it and submerge it in hot water with a thermometer. It should open at the specified temperature, typically between 82 and 88 degrees Celsius. The replacement of the thermostat is economical, between 30 and 80 euros, and includes the gasket. The location varies by vehicle but is generally in an aluminum body that connects with the upper radiator hose. Air in the cooling system also causes erratic temperatures. Bleeding is necessary. Reason 4. Stuck EGR valve. The stuck exhaust gas recirculation EGR valve contaminates the intake mixture. The EGR recirculates a portion of the exhaust gases to the intake to reduce combustion temperatures and NOx emissions. The EGR valve becomes carbonized by residues and soot, becoming stuck open or closed. The EGR stuck open allows exhaust gases to contaminate the intake constantly, and the engine works with a lean mixture. The dilution of the air and fuel mixture with inert gases reduces power and generates irregular idle. The EGR stuck closed does not recirculate gases, combustion temperatures are high, and NOx emissions increase. On days when the engine is cold, the EGR is closed by normal operation and the engine responds well. On days when the engine is hot, the EGR must open. If it is stuck open, performance is poor. The symptom is irregular and unstable idle, loss of power in acceleration and hesitation. The check engine light with codes P0401 for insufficient EGR flow or P040DOOS for excessive EGR flow. Black smoke from the exhaust due to rich mixture compensation by the ECU with the EGR stuck open. Verification is a visual inspection of the EGR valve looking for carbon accumulation with the stem stuck. Disassemble the valve and clean with carbon cleaning chemicals and a wire brush. Cleaning the EGR valve is a preventive maintenance procedure every 80 or 100,000 kilometers. Replacement of the EGR valve costs between 200 and 500 euros for new ones. Reason 3. Weakened ignition coils. Weakened ignition coils generate inconsistent spark under load. Ignition coils transform the 12 volts from the battery into thousands of volts necessary to generate the spark in the spark plugs. Coils age, internal resistance increases, insulation deteriorates, and efficiency is reduced. A weak coil generates sufficient spark with the engine at idle with low demand. But under load in acceleration with high demand, the coil does not generate sufficient voltage and there are misfires. On days of low temperature, electrical resistance is lower and coils function better. On hot days, resistance increases and weak coils fail to generate adequate spark. The symptom is misfires in acceleration. The engine shakes and there is momentary loss of power. The check engine light with codes P0300 to P0308 for misfires in specific cylinders. The engine functions well at idle but fails under load or strong acceleration. Verification is done with a scanner viewing real-time data to see if misfires increase in acceleration. The oscilloscope to see the ignition pattern is ideal but requires specialized equipment. You can swap coils between cylinders to see if the failure follows the coil when it moves from cylinder. The primary and secondary resistance test of the coil with an ohmmeter is compared with specifications. If the resistance is out of range, the coil is defective and replacement is necessary. Individual coils per cylinder cost between 40 and 100 euros each. The coil pack for multiple cylinders costs between 200 and 500 euros. Deteriorated high-tension spark plug wires also cause similar problems. Inspection and resistance. Humidity in the wires or spark plugs causes short circuits where the spark escapes to ground. Reason 2. Throttle body with dirty butterfly. The throttle body with dirty butterfly generates partial obstruction of the airflow. The throttle body controls the amount of air that enters the engine. The butterfly valve opens and closes. The butterfly accumulates carbon and oil deposits from the crankcase ventilation and recirculated exhaust gases. The deposits reduce the opening area. Airflow is restricted, idle is low, and affects throttle response. On days when the deposits are dry and hardened, the obstruction is greater. On humid days, the deposits soften and the obstruction is less. The variability of ambient humidity and temperature affects the consistency of the deposits and the behavior of the engine. The symptom is unstable idle that fluctuates in RPM with the engine hot or cold. The throttle has slow response. When the pedal is pressed, the engine takes time to react. The check engine light with codes P0505 or P0506 for idle control system out of range. The engine shuts off at traffic lights because the idle drops too low. Verification is visual inspection removing the inlet duct to see the butterfly directly. Black deposits accumulated on the edges of the butterfly and the throttle body indicate that cleaning is necessary. Cleaning is done with specific throttle body cleaner spray. Never WD-40 because it damages the sensors. You apply the spray with the butterfly open to clean the deposits with a cloth. Engine off and disconnect the battery. Reason 1. Engine control module ECU PCM with software glitch. The Engine Control Module ECU or PCM with software glitch, erroneous adaptations or corrupt memory is reason number 1. The ECU is the brain of the engine. It processes information from the sensors and controls the injectors, ignition and systems. The ECU software has complex algorithms and adaptations. It learns the behavior of the engine over time and adjusts the parameters. Adaptations in the ECU memory can be corrupted by low battery voltage, sudden disconnection or electromagnetic interference. A corrupt ECU generates erroneous calculations of fuel mixture, ignition timing and systems control. A temporary software glitch causes erratic behavior of the engine. Days it functions perfectly, others it responds poorly. The ECU stores permanent, pending and historical fault codes that can affect the control strategy. There are days in which the ECU reads the sensors correctly and the engine functions optimally. Days in which the readings are erratic, the processing is incorrect and the response is poor. The symptom is completely unpredictable and erratic engine behavior at idle and acceleration. The check engine light is intermittent. It turns on and turns off with codes from multiple systems. The engine enters safe mode, limp mode, with reduced power to protect from damage. The ECU reset, disconnecting the battery for 15 minutes, clears adaptations and temporary memory. The engine functions better immediately after the ECU reset, but then the erratic behavior returns. There you have the 14 reasons why the engine does not respond the same every day. Worn APP sensor, dirty air filter, carbon accumulation in valves, contaminated MAF, worn spark plugs, weak battery, contaminated fuel, defective ECT, fluctuating fuel pressure, stuck thermostat, carbonized EGR, weakened coils, dirty throttle body and ECU with glitch or corrupt.